One of those really fun party trick brushes of Substance Painter is the particle brush, with which I can, well, paint particles onto an object, which in turn will run down its surface, leaving some nice streaks behind. Houdini has had particles for ages and now also has a really nice texturing workspace with Copernicus, so let's see if we can rebuild them here. I'm starting out not with an empty scene, but with the same fire hydrant that I used in my last Copernicus tutorial. If you want to know how I got here, you can watch this tutorial, linked in the description. But now let's use this fire hydrant and first of all paint some particles onto it, and for this I'm going to use the really old spray paint node because, well, that's exactly what this node is supposed to do. Let's fire this in. Let's first of all tweak the brush settings on here. I'm going to use a really high spray rate of 60,000, and under radii I'm going to make the point radius scale quite small, a value of 0.01, like this. And now to see better what I'm doing right here, I'm going to enable the display flag here on my main null. I'm going to leave my spray paint node highlighted, and I'm going to select my handles tool. I'm going to make the brush size a lot smaller by scrolling down on my scroll wheel, and I'm going to start painting some nice particles in some areas where I want them to appear. Maybe something like this for now, and you of course can get a lot more creative with this. Let's hit escape, we are done here. These are the particles that we created. Now on those particles we have a bunch of attributes. The one that I'm mostly interested here is the p-scale attribute. I can ignore pretty much everything else in here. And I want to work on this p-scale attribute a bit more. I want to add a bit more noise to it, just to break up the shape of these streaks in the end a tiny bit more. For this I'm going to use an attribute noise float, in this preset right here. This is already set up to work on a p-scale attribute. And I'm going to set the noise value or the noise operation to multiply. I'm going to give it an amplitude of, let's say, around 3. I want to enable a remap ramp and bring up the lower end a tiny bit, like this. And I want to tweak the element size, make this really small, a value of 0.05, and also tweak the offset a bit, value of 2, and these are just values that work nicely for me in this case. Now before I turn this into particles, there's one additional attribute that I want, which is a mass attribute, which will control how far those particles are running down the object. And I want to base this mass attribute simply on my p-scale attribute, and for this I'm going to use one very simple and actually the only point wrangle in this entire setup. So wire this down, and in here I want to simply say f at mass is equal to f at p-scale. Just make them the same value. Now with this we can finally jump into a pop network, so let's create one. Let's jump inside. First of all, let's work on a pop source. I want to use all points. I want to use them from the first context geometry like this, and under birth and the impulse activation I want to set this to be just active on the first frame, so $f == 1, like this. I also want to have gravity in my scene, so let's drop down a gravity force. Let's turn the gravity down a bit, make those particles fall a bit slower. Let's turn this to -1. And let's also use a pop drag node. And in here I want to uncheck ignore mass, so that the large droplets will fall faster than the small droplets. And if we play on a timeline now, this is exactly what we're seeing right here, which I think is looking quite nice. Now currently our points are just falling down, they're not sticking to the surface of our object. Let's tackle this next. For this I'm going to need a pop wop in here. On this pop wop I need a reference to my surface. For this I'm going to the input step right here, and I'm going to change the input to a sop. And for this sop I'm going to select my main null, which is my fire hydrant. Let's like this, hit accept. Now let's jump into this pop wop. And in here, all I want to do is modify the P attribute, and I want to modify it with a min pos, with a minimum position node, because in here I can wire in my surface. This is the second input that we selected, and this goes into the input here. And from my current point's position, I want to find the position closest to that point on the surface of our object, and I'm going to write this out again as a position like this. And now if we jump out of this, and again take a look at our pop network, now we can see that those particles are following the shape of a fire hydrant, like this. Let's jump back out. Now the popnet has created a ton of attributes on our points, so let's first of all clean this up a bit with an attribute delete. Let's select delete non-selected, and let's select the attributes that we want to keep. And in this case, this will be just our P attribute and our P scale attribute like this. Now let's turn those single particles into actual trails, into streaks. And for this, I'm going to use a trail sub, where this then set the mode to connect as polygons. Let's uncheck close rows. And let's set the trail length to our current frame number, so $f, so now our particles are leaving some nice trails behind. Finally, let's select a frame that we like, maybe frame 96, and let's use a time shift to lock this animation in place. And simply on here, right click on the frame parameter, and let's select delete channels. Now this is locked into a single frame. And I know that Substance allows you to live paint particles and watch them simulate and run down the object at the same time. However, that would be much more work to implement here in this scenario in Houdini, so I'm leaving this challenge for another day, basically. I'm happy with what I'm getting here. Now, with this done, I want to create some additional attributes that we're later going to need to bring this into Corps. And first of all, I want to have an attribute simply as a helper that is 0 here where each point starts and is 1 where each point ends, and this is a curve view attribute, and I can create this with a resample node. Where this down below. On this resample node we should tweak the point spacing. For this scene right here, again I want to turn this down fairly small, value of 0.0005 to give me a lot more points later to work with, and I'm going to need a curve view attribute, which I'm going to enable here. Now what I want to do with this curve view attribute first of all is control the P scale attribute, because this should start quite large on the top and get smaller the further our droplet travels down. For this I'm going to need another point warp. Wire this down. Let's call it P scale ramp like this, and let's jump inside. In this point warp I first of all want to bring in my P scale attribute, so let's use a bind node for this. And let's also bring in our curve view attribute, another bind like this. And I want to run this curve view attribute through a ramp parameter, which I'm going to set to a spline ramp. And then let's make a bit more room here. Then I want to multiply my P scale by that ramp. Wire this in here, and let's finally bind export this again as a new P scale attribute. Like this, and this is my node tree in here. Now let's tweak this ramp. Let's first of all bring the lower end up, and then let's create a second point right here in the middle and drag this all down to 0, and then select all 3 points and set the interpolation to Bezier to get this nice ramp where P scale gets smaller and smaller and smaller. And to quickly demonstrate what I did here, I'm going to quickly drop down a sweep node. Let's find first of all just a resample. In here set the surface shape to round tube like this, and let's set the radius to 1, and let's turn off point display here. And right now we just have one single tube with one single thickness running down, which is not very realistic. However, as soon as I plug in my P scale ramp, now I have this really nice transition from a thick start to a very small, very narrow end like this. Taking a look at our parameters now, the one very crucial thing that this is still missing is a UV attribute, because we need this later to actually put our droplets or streaks onto our object, onto the UVs of our object. So let's copy those from our main object up here next. For this I'm going to need another point warp. Let's call this copy UV. And let's branch out from a main node up here. Let's add a reroute by alt-clicking here, add another one by alt-clicking here, and then wire this into the second input of our point warp in here. Now let's jump inside. Now the first thing that I need is the closest position of one of our particles to the surface. And in this case I'm not going to use the same minimum position node that I used in my PopNet. In this case I'm going to use an XYZ dist node. On the input side, this works pretty much the same as our min-pos. So we first of all need to reference our surface geometry, which is our input 2, and the position that we're looking from, which is our position. However, what this node in this case gives us as an output is not a position, but a primitive and a prim-UV coordinate. And these are quite important because I can use those with a primitive attribute node, where I can plug in again my surface geometry and then also this primitive and UV parameter right here. And this in the end will give me a very, very accurate way to get the UVs from my main object onto my streaks in here. So it's finally on this node specified that we want to write out a UV attribute, and then finally write this out with a bind export again. Call this UV, and this should be a vector like this, and let's wire this in. Now we're almost done with our attributes. The final thing that I want to add to my geometry here is a color, and I want to simply use a ramp that starts out white at the start and ends up black, simply because I can later use this to sort of fade out all these streaks as well. Let's drop down a color node, wire this in, set the color to ramp from attribute. Let's use our curve view attribute again. Let's flip the ramp range like this, and in the end I brought the wide end down a bit, maybe to something like here, and this worked nicely in my case. Now finally we have all the right attributes on our geometry right here, and again this is a p-scale attribute, a UV attribute, and a color attribute, and of course a position. We have all the right attributes to finally bring this into Corps and use as a brush. So for this, let's drop down a null. In this case, I'm going to call this stamp points because this is also the name of the Corp node that I'm going to use for this. And now let's bring in a Corp net, highlight it, dive inside. Let's first of all bring in our main SOP geometry. Let's use the SOP import, use external SOP, and select our main fire hydrant again. And let's use a preview material again to preview our streaks in the end. Now let's bring in our streaks. So for this, I'm going to copy the SOP import node one more time. And in this case, I'm going to select my stamp points like this. Now I have to bring those points or those trails into UV space. For this, again, I'm going to use a rasterized setup. And I'm going to set the space to UVs like this. And right now we're getting those really stretched lines where points or lines are between two UV islands. However, in this case, we can just ignore those lines. Let's maybe make some more room here. We can mainly ignore those lines because the node that I'm going to use in a second just worries about the points position. And we have only points on those UV islands. So the node that I'm going to use now is called stamp points. And this is simply a Corps version of pretty much the copy to points node, where you can think of it like this. I can wire in my points in here, and this node will copy some stamp geometry onto those points, as we can see right here. Now we have a few things to set up. First of all, the resolution of my CorpNet is quite small, and I could jump out and change it on the top level of my CorpNet. However, I can also use this resolution button up here and simply set it to 4K, which is my sort of standard texture resolution. And now this looks a lot more high res. Also on my stamp points, because I later want to use this as a mask, I'm going to set the type or the signature to mono, something like this. And you can already see all those streaks right here on the map. Let's maybe focus on this set of streaks right here. And now I could use some of those preset shapes right here. However, in this case, I want to create a shape myself that I want to copy onto this point. And in this case, I'm going to use as a base one of those new SDF nodes that we have in Copernicus. I'm going to start out with an SDF shape, which is a circle. I'm going to halve the radius of that circle to a value of 0.5. Then I need to turn this SDF circle into a mono texture. So I'm going to use an SDF to mono to do that. Right now this has a really harsh transition from white to black. I can use the smooth operation down here to break this up a bit. Let's set this to a value of 0.3. And let's also tweak the ISO offset a bit, maybe to a value of 0.018. That looked nice for me, just as it's a little bit closer to the edges here. And I want to turn this into sort of a paintbrush, and right now this is way too smooth, so let's break this up a bit. In the end, I want to use for this a distort node, and I can wire in my object or my picture in here. However, to distort this, I need to use a direction map, and I can create this first of all by using a fractal noise. And on this fractal noise, I'm going to set the element size to a value of 0.15. And I'm also going to lower the roughness to a value of 0.3 like this. This worked nice in my case. And then I'm going to turn this fractal noise into a direction with a slope dir node, slope direction. Our noise goes in here into the height input, and now we have a slope direction output and this map that encodes that slope direction. Let's wire this into the direction. We can see a bit happening right here on our distortion. We can make this a bit stronger. Let's maybe make this a value of 0.09. And I think this is quite a neat looking paintbrush. So finally on our stamp points, let's wire this into the stamp 0 input. And let's tweak the scale a bit. It's quite small right now, so let's turn the scale up, let's say to a value of 3. Yeah, and I think this looks a lot more like paint streaks. So finally, let's preview our mask. Let's simply wire the output of a stamp right here into the input of a base color. And taking a look at our fire hydrant, we have some nice streaks going on here. So at this point, you can change the settings on the stamp points node, maybe the scale or the angle. You can also play with the resample length on this resample node if you're getting too much separation on those paint lines. And of course, in general, you can play with all those different ramps that we created in here and also with the popnet settings to get the effect that you want. And also, of course, what we created in here in our corpnet is basically just a perfectly fine mask. So you can use this to, for example, blend between two PBR materials like we did in the last episode. So this is all I have to tell you for today. And until next time, it's cheers and goodbye. And if you like what we're doing, please consider becoming a patron of ours. Not only for supporting Attackma, but also for access to in-depth courses on topics such as KineFX, Vellum, Vex, Python, and maybe some future courses very, very soon. And also let me say thank you so much to all our existing patrons. Without you, this channel would not be possible. Thank you.